This video is about graphing trigonometric functions. And in my experience with tutoring students, I have found that this is one of the more challenging concepts that students face and struggle with in pre-calculus. So if you are struggling with this idea, you are by no means alone. And I hope that this video series will help you understand how to graph trigonometric functions. In this first video, I will talk about how to graph sine of x and cosine of x. Okay, and before we get into graphing it, looking at these graphs, I want to first review the fact that we're looking at and working with the unit circle. And the unit circle is a circle where the radius is 1. Okay, so as I rotate this point around, the radius will always be 1. Okay, and I'm thinking about most graphs, we're looking at the x-coordinate and the y-coordinate. Okay, but trigonometric functions are a little bit different in that I'm looking at this angle right here and how that affects the sine of x and the cosine of x. Okay, so let's kind of, I know it's a little fuzzy right there, but let me kind of keep going. And we're looking at sine of x and cosine of x. So let's review quickly what sine of x and cosine of x are. And the acronym that I have chosen to use is SOHCAHTOA. It's a very common acronym that teachers use. And the sine is equal to, the sine of x is equal to the opposite divided by the hypotenuse. Okay, now keep in mind that our hypotenuse is going to be 1. And this is our angle right here, and I probably should not use x to not confuse you. I'm going to use theta instead. So this is theta, and the sine of x is the opposite over the hypotenuse. Now this is the opposite right here. Okay, but the hypotenuse is 1, which is very useful to us, which is why we're choosing to use the unit circle. So this is going to be the y-coordinate. Sorry, try. Over 1, okay, which simplifies to just being the y-coordinate, which means that wherever I am on the unit circle, whatever the y-coordinate is going to be the sine of x. Okay, that's very, very useful to us. Okay, similarly, the cosine of theta, that angle, is the, let's see here, adjacent over the hypotenuse. Okay, now the adjacent is going to be down here, which happens to be the x-coordinate over 1, which is just the x-coordinate. Okay, so the way I think about this, I'm a very visual person, but whenever I think about this, I think about the y-coordinate, this coordinate, this vertical distance. I need to erase that now that I don't need that anymore. This vertical distance is the sine of x, and the this horizontal distance, the x-coordinate, is the cosine of x. Okay, I think about rotating that around where the independent variable I'm graphing down on the x-axis will be theta. Okay. Now it's very useful for us to have a few numbers to kind of plot as we're graphing this. Okay, and the ones that we'll tend to use are these, which are special right triangles. Okay, I'm hoping you have some experience with special right triangles from past classes. If you do not, I do have some videos called 8-2 special right triangles on my YouTube channel that might be of use to you. Okay, but keep in mind that our hypotenuse is 1 because we're on the unit circle, and so these lengths on these 30-60-90 or 45-45-90 right triangles turns out to be 1/2 and root 3 over 2. This is root 2 over 2, root 2 over 2, and this is root 3 over 2 and 1/2. So those are numbers that will keep popping up for us because we're using these triangles. With that in mind, we are going to start looking at the graph of y equals the sine of x, where x is our angle. Okay, also keep in mind that we're looking mostly at our y-coordinate. Okay, because that gives us the sine of x. Okay, and for simplicity, I'm just going to focus on the pi fourths and pi halves and 3 pi fourths, focusing mostly on our 45, 45, 90 right triangles instead of being too precise looking at the 30, 60, 90 triangles as well. Okay, so let me start off with an angle of 0. At an angle of 0, my y coordinate is 0, okay, which is a really good anchor point for the sine of x as it goes through the origin. Okay, if I go up here somewhere around pi fourths, this y coordinate is root 2 over 2, or about 0.7. And so this is about yes, it's about 0.7, about right there. Okay, now if I keep going to pi halves, I'm all the way at the top. So I'm all the way at the top here, pi halves, I'm at 1. If I keep going to 3 pi fourths, then I'm going to have it's positive, right? It's above the above the x-axis. It's still root 2 over 2. I go over here at root 2 over 2, which is again about 0.7-ish. Okay, now I keep going at pi. At pi, I have a y-coordinate of 0 again. Okay, keep going. I'm now below the x-axis, so it's negative, and it's going to be a negative root 2 over 2. So down here, this is a negative root 2 over 2, about down there. Now if I keep going, I'm at 3 pi halves. I'm at negative 1. 3 pi halves, negative 1. Okay, and if I keep going, then I'm at 7 pi fourths, which is again still below, it has a negative y coordinate, negative root 2 over 2, which is about right there. And then I come full circle at 2 pi, and I'm back at 0. Okay, now if I do this a little smoother, it would look something like that. Okay, now keep in mind that I could keep, the angle could continue, right? So this does actually continue on in both directions. Okay, but roughly that is our sine curve. If you want to look at a better example of what this would look like, here is one right here, and this is the sine of x. Okay, again, notice that it crosses here at 0, 0, and this has a period of 2 pi, meaning that it'll go through a full cycle in 2 pi. And we'll talk more about periods as we begin transforming these a little later. Okay, but this is what the sine of x function looks like. Okay, let's go back and now look at the cosine of x. Okay, now we'll do a similar thing for the cosine of x. Y equals the cosine of x. This is, again, still the angle. But for the cosine of x, we're looking mostly at the x-coordinate. Okay, so start back here. Now, if the angle is 0, the x-coordinate happens to be 1. Okay, so it starts off here. The cosine of 0 is 1, which is a good anchor point for the cosine of x, that it will go through, it'll cross the y-axis at 1. Okay, if I go up here at the at pi fourths, this is root 2 over 2. So graph here at pi fourths is about right here. Okay, if I keep going at pi halves, the x-coordinate is 0. So I'm down here at pi halves, it crosses the x-axis. Okay, keep going. Whoops. I keep going. This is the x-coordinate here now is negative. It's negative root 2 over 2. So I'm actually below the x-axis on this graph at negative, about right there. And then if I come over here to pi, then my x-coordinate is negative 1. Oops, change colors. Is it negative 1? So at pi, I'm at negative 1. Okay, I keep going. The x-coordinate is still negative, negative root 2 over 2. And this is a negative here. If I keep going at 3 pi halves. Again, the x-coordinate is back at 0. So I'm back at 0. And if I keep going, whoops, if I keep going, it's now positive. This is now a positive root 2 over 2. And so I'm back here up positive. And then finally, to come full circle, back to 2 pi, my x-coordinate is, again, 1. Okay, so here's a bit of a smoother graph. Looks something like this. Okay, and again, this will continue on in both directions. And a smoother curve would look something more like this. This. Okay, notice that it crosses the x-axis at 1. That's the anchor point that I keep in my mind for how to graph the cosine of x. Okay, so in this video we talked about graphing the sine of x and the cosine of x, and we'll talk about other graphs in future videos. I hope this video was helpful for you. Thank you.